नहीं कर पाएगा सर।
चैट जीपीटी को तो उसका नाम लिख दे, प्रॉब्लम का पूरा कोड कर देगा जो अभी है नेक्स्ट असाइनमेंट का। भाई कॉल एक्सेस की 5 लाइन
ऐसा है क्या?
अबे वो प्रॉब्लम तो वही है ना, प्रॉब्लम का नाम तो लिख देगा तो उसको कोड करना,
पर उसमें लिंक लिस्ट बनानी है।
लिंक लिस्ट नहीं बनानी।
हाँ बोल रहे हैं नोड वगैरह की।
एवीएल ट्री
मैं थोड़ा क्लास नहीं आया हूँ, पढ़ना पड़ेगा।
ट्री पॉज लिंक लिस्ट। मैं तो क्लास गया था कल, कुछ समझ नहीं आ रहा क्या बहुत चूतिया पढ़ा पर आज ऐसे ही पेपर पढ़े थे। सिस्टम से ये डीएफएफ तो डीपी कर रहा है, वही तो वाइट डीपी अबे नहीं वैसे नहीं कहता था भाई। अबे क्या मूव नॉट मूव ये सब क्या है आप नहीं अनुराग तिवारी कांजल बैंसला स्पर्श एक ही बाकी दो लोग का है। पिछले 3 बार इसका दोनों का साइन मार लगा रहे हैं। पिछले 3 बार से अनुराग एंड प्रांजल का और स्पर्श आपका भी एक इसके पहले वाला एक लगा है ना। let me find out who is marking this. Anybody knows them? Sanjay and Anurag. कोई जानता है इनको?
Yes sir.
वो कहाँ है?
बता दे.
इनका नंबर है?
हाँ.
क्यूपिड ट्वीट लगा रहा है ना सबके.
पहले कोई इन्होंने कुछ ऐसा कोई आविष्कार तो नहीं किया जिससे इनविजिबल हो जाते हैं. क्लास में साइन मारने के बाद इनविजिबल.
कौन जानता है?
यही जानता है और तो कोई
सर
नहीं.
कॉल कर बताओ नंबर तो कुछ तो इसका
नंबर तो बता दे यार. कॉल मत करो, मैसेज कर दो कुछ अच्छा नहीं है. क्या हो सकता है?
कितना
Those who have marked proxy for these two students, please come forward and tell us who marked it. If you come forward and tell us who marked it, there is only a mild punishment. Because since you have accepted, there is a mild punishment. But if I make an effort to find out, I will find out eventually. If I find out, then there is no punishment. Then there is a, I will forward this case to disciplinary. I will forward this case to disciplinary. If you accept, then that matter stays here, it ends here. Okay. Correct? So please, those who have marked the proxy for these two students, please come forward and accept. There is nothing wrong in accepting if you have done something which is not correct. Okay. अगर आपने कुछ गलत किया, मान लिया है, हम भी मान जाएंगे ठीक है आपने गलती कर दी. Matter ends here. But if you don't accept, and if I find out, that means you are not accepting your guilt. Okay. Then I will find out. And I will forward this to the disciplinary committee. वो पता लगा लेंगे किसने, मैं भी पता लगा सकता हूँ भाई कि who marked their proxy. तो बेटर ये है कि अभी आपके पास टाइम है, एक्सेप्ट कर लो जिसने प्रॉक्सी लगाया है. प्लीज एक्सेप्ट ऑनरेबली, देयर इज ऑनरेबल पनिशमेंट. मैटर एंड्स हियर. अगर आपको खेलना है कमेटी तो खेलते रहेंगे, बात ठीक है. आई हैव नथिंग अगेंस्ट दैट, इट इज एंटायरली अप टू यू. 5 मिनट के अंदर जिसने मार्क किया है प्रॉक्सी आप बता दो, नहीं तो अदरवाइज आई विल फाइंड. इट इज इजी टू फाइंड आउट जस्ट बाय लुकिंग एट द राइटिंग इटसेल्फ. ओके, सो प्लीज किसी ने अगर मार्क किया है अभी तुरंत बताओ. There is only a mild punishment I am saying again and again. Okay. आरुष रंजन कौन है? आपने प्रॉक्सी लगाई इसकी प्रांजल की. Why your page is matching? Why your writing is matching? नहीं लगाया? पक्का? अगर लगाया है तो अभी टाइम है, बता दो. बहुत ही माइल्ड पनिशमेंट मैं अभी बता रहा हूँ, अभी भी बता रहा हूँ मैं. If you accept there is only a mild punishment, I will give assignment and matter close here. If I find out there is no assignment, I will take your 10 marks. I will send this to disciplinary committee and I am damn sure you will get a fail grade here. And I don't give, usually I don't allow any of the students to do the self study in my course. You ask anybody, I have never given a self study in my course. अभी चांस है, honorably accept कर लो and matter ends here. And I hate cheaters big time. अगर किया है तो अभी तुरंत एक्सेप्ट कर लो. There is the only punishment of assignment. Nothing will take, I will not take anything from you, except you will have to write the assignment. That's it. नहीं बताना चाह रहे? एक तो आपने बताया ना, तो you will get the assignment. Okay. वो पता लगा लेंगे हम, वो हम पता लगा लेंगे, टेंशन ना. नहीं है तो हम पता लगा लेंगे। हमारे पास बहुत रास्ते हैं। I have been modern for 10 years. I know different ways of finding out. Okay, so I will find out. आपके लिए असाइनमेंट ये है दोनों के लिए। अब तक हमने कितने चैप्टर कंप्लीट किए किताब में?
10
फर्स्ट ऑर्डर कौन सा चैप्टर?
10
चैप्टर है ना, तो अप टू 10 चैप्टर ऑल द सॉल्व एग्जांपल इन द बुक यू हैव टू राइट एंड सबमिट ऑल द सॉल्व एग्जांपल। अगेन यू राइट इन योर ओन हैंडराइटिंग एंड यू सबमिट। ठीक है, यही पनिशमेंट है
चैप्टर 3 and 6
सभी के, स्टार्टिंग फ्रॉम चैप्टर 1 टू चैप्टर 10 all the solved example in the book you have to write and submit. That is the punishment. ये दो लोग जो बचे हैं इनके लिए कुछ बड़ी punishment। They are not accepting and they are not coming. अब कौन है या ये कौन है इसका पता लगाते कौन है। So I did not get a time to do the engineering on this. इन दोनों को एक बार कॉल लगाओ। एक है अनुराग तिवारी एंड प्रांजल भाई, इनको लाओ वीडियो कॉल करो।
सर प्रांजल आर्या, प्रांजल आर्या, अनुराग का नंबर नहीं है मेरे पास।
प्रांजल आर्या का है,
मतलब प्रांजल आर्या है।
इसका
अच्छा प्रांजल इसका है, सॉरी मुझे लगा लड़का है। अनुराग तिवारी आप हो? हेलो हाँ भैया, आप तो बड़े स्पेशल आदमी बने हुए हैं। नहीं तो आप तो काफी क्लास से नहीं आ रहे, बट एक आपके कोई दोस्त है बहुत रेगुलरली आपकी अटेंडेंस लगा रहे हैं। ठीक है, अरे भाई आप ये मत बताओ मुझे, आई हैव बीन हियर सिंस लॉन्ग टाइम। ठीक है, मुझे सब पता है। आपके जो साइन है ना वो देख के समझ में आ रहा है कि कोई तो लगा रहा है, पिछले 3 दिन आपको लगा रहा है। अब ये बताओ किसने लगाया? तुम्हारे पास रास्ता है, तुम अभी तुरंत बता दो कि किसने लगाया। ठीक है, बताओ किसने लगाई? आपने किसको बोला? कौन है? 1-2 जन, वो दोनों जनों का नाम बताओ। नाम बताओ तुरंत, नहीं तो तुम्हारा केस को मैं भेजूंगा, तो तुम्हें दूंगा एफ ग्रेड अगर तुमने बताया ना। अभी बताओ। परम शाह, कौन भाई? परम शाह खड़े हो जाओ। और दूसरा परम शाह, शाह परम रौनक कहा भैया? कौन है शाह परम रौनक? इजी है, इसको नोट डाउन करो यार, परम शाह का नाम याद रखो। चलो ठीक है, इसको ही बोला है। तो आपको दोनों को, आपको पनिशमेंट ये है कि अब से 10 चैप्टर तक के जितने भी सॉल्व एग्जांपल है किताब में वो जमा करोगे। अगर नहीं जमा करोगे तो आई विल गिव यू अ फेल। ठीक है, वो जमा करना है माइनर के पहले। बिफोर माइनर एग्जामिनेशन यू हैव टू सबमिट ऑल द सॉल्व एग्जांपल गिवन इन द बुक। यू हैव टू राइट इन योर ओन हैंडराइटिंग। किसी दुनिया से कराना नहीं है, तुम्हारे अपने हैंडराइटिंग में कराना और जमा करना। ठीक है, और नहीं जमा करोगे फेल ग्रेड मिलेगा। ठीक है, तो पाव शाह का नाम याद रखिए, दूसरा को नहीं बताओ, दूसरे का भी पता लगा देना। कहानी हाँ भैया बताओ कितने लगाए? नहीं देखो, आप अगर एक्सेप्ट करोगे और बताओगे तो पनिशमेंट ही असाइनमेंट, इससे ज्यादा नहीं जा रहा। अगर नहीं बताओगे तो फिर मेरे पास रास्ता ही नहीं है। आई हैव टू सेंड दिस। कोई भी है जो किसने लगाया? किसने? अभी रास्ता में तो दोनों का केस देते हैं क्योंकि यू आर नॉट ऑनरेबल। नहीं वो क्या बोलूं, नाम बताओ। देखो पनिशमेंट सबको पता है क्या है पनिशमेंट, केवल असाइनमेंट। आप नहीं मानेंगे, नहीं बताएंगे, आई विल सेंड ब्लाइंडली। आई विल सेंड डिसिप्लिनरी कमेटी। आप सुनते रहो, वहां एप्लीकेशन देखते रहो, मुझे कोई आता अंदर एबी का भी बताओगे, असाइनमेंट का पनिशमेंट बताइए। आरुष कौन है भैया? आरुष, हु इज आरुष? है आरुष यहाँ? यहाँ कहाँ है नाम बेटा बताओ? आरुष कहाँ? आरुष था क्या उस दिन? पहले ये तो चेक कर ले। आरुष, चलो आरुष और इसको कल को याद रखो, ठीक है? आपका पनिशमेंट ये है बेटा, आपको सबमिट करना है असाइनमेंट्स अप टू 10 चैप्टर, ऑल द सॉल्व एग्जांपल गिवन इन द बुक यू हैव टू सबमिट बिफोर द माइनर, दैट इज द पनिशमेंट, अदरवाइज आई एम गोइंग टू सेंड, ठीक है? आरुष आएगा तब पूछेंगे ना, कोई बात नहीं, कोई बात नहीं, कोई बात नहीं, टोटल रिकॉर्ड आपका थोड़ी ना होगी, वो अनइथिकल चीजें कर रहा है, कोई मुझे बोलेगा जाके चोरी कर तो मैं कर दूंगा, ठीक है? ही इज इक्वली रिस्पॉन्सिबल इन दिस, ठीक है? डोंट ट्राई टू, उसको आप ये नहीं करिए, शील्ड नहीं, ठीक है? ही इज इक्वली रिस्पॉन्सिबल, ठीक है? चलिए आप जाइए बैठिए, ठीक है? अब से ये दिस इज द फर्स्ट एंड द लास्ट मिस्टेक हो गया ना, नहीं इसमें कुछ नहीं, उसको भी यही पनिशमेंट मिलने वाली है अगर एक्सेप्ट करेगा, नहीं करेगा तो मैं आगे जाएगा, क्या कर सकते? एक्सेप्ट करो और आगे बढ़ो, है ना? आइए, this is the last time I am giving this punishment. Next time if I find out anybody doing such unethical things in my class, cheating I hate big time. In my course everybody get a fail pass grade, fail grade is exceptional case. But अगर आप cheating करोगे, I will not hesitate to give you fail grade. I will not hesitate to give you a fail grade, and I am telling you again and again, no matter how many years you spend here, उसका सेल्फ स्टडी नहीं होगा, ध्यान रखो, सेल्फ स्टडी मिलेगा नहीं, क्योंकि ओनली आई एम गोइंग टू अप्रूव, और मैंने आज तक अपने कोर्स का कभी भी सेल्फ स्टडी किया नहीं। यू डू इट ऑनरेबली, आपको कम मार्क्स मिल जाए, आई एम ओके विद दैट, देयर इज नो प्रॉब्लम। सी आई एम नॉट, if you are getting less marks, perfectly all right, I am not going to remember your marks, but if I see you doing a cheating, I am going to remember you, even after 10 years you will come back and I will still have that memory कि आप एक cheater है, ठीक है? If you get less marks, it's not the problem. Chemical engineering is not everything, you can do many better things outside. And I am not going to remember your grades, not going to remember your marks, but I am going to remember what type of person you were here. That is what I am going to remember. Okay. So please don't be cheater. There are so many IITians, isn't it? They have raised up their mind in quota, primarily because success at any cost. That is what you have learned, isn't it? Success at any cost is not the everything. You have to get success honorably. Okay, if you get the success honorably, then people will respect you. Otherwise, nobody will respect you. चीटर का कोई इज्जत नहीं है बाहर की दुनिया में, ध्यान में रखो इस बात पे। कम मार्क्स मिल जाए चलेगा, चीटर नहीं बनना है, चीटर नहीं बनना है, ठीक है? So this is the first and the last mistake. If I find out anybody doing cheating, इसके बाद कुछ नहीं, हम सुनवाई करेंगे, उसका केस हम फॉरवर्ड कर देंगे और उसको देंगे F ग्रेड, वेरी गुड, अभी से हम बता, ठीक है? तो वी स्टॉप हियर, वी स्टार्ट विद व्हाटएवर वी हैव, इनका एक्सेप्ट कर दो फोन करके जो है, और पर और कौन नाम है मतलब आई, इनको आप याद करेंगे, ठीक? हाँ, वेयर वी हैव बीन फर्स्ट ऑर्डर पर, in the last class we started looking at first order process. We said first order process are those processes in which the model equation is first order differential. When we apply the Laplace transform to such equation, what we expected to get is we get the transfer function which is Kp divided by tau c s plus.
equation Kp is a process gain, which is given as change in the output divided by change in value. And tau p, which is nothing but the time constant of the process. Time constant of the process, physical significance of the time constant is, it is nothing but capacitance multiplied by resistance. Typically, first order processes we get whenever there is a capacity to store mass, energy and momentum, and there is a resistance to flow of this quantity. Then we get a first order, isn't it? After that, we started looking at pure capacitive process. So in a pure capacitive process, we have only the capacity to store mass, energy and momentum. There is no resistance. There is no resistance. Typical transfer function we get for a pure capacitive process is Kp divided by S. Okay. Then we started looking at the response of the first order process. We say in this case, if we take a step input of magnitude unity, in that case, typically we get exponential response. Exponential response. So you can see that as the disturbance comes into the system, the output is going to increase or decrease depending on whether the step input is positive or negative, and it will settle to a new steady state value. Isn't it? So you will see that the output is not becoming unbounded, and therefore we call the first order process as self-regulatory. Self-regulatory. Because you will start from one steady state point and you will reach to the another steady state point and this is the distance. Okay. These are some of the salient features which we have seen. The first salient feature here is if we continue with the same speed of response, in that case the entire response is going to complete in one time. Okay. Another salient feature is in one time constant, the response is 63.2% of the ultimate response. Typically, we reach to the ultimate response when the time is beyond 4 time constants. Okay. So this is what is written here. Again, the smaller is the value of time constant, faster is the response. Then its speed of response depends on time constant, and that is why this constant we have defined as a time constant, because it gives you a speed of response. Correct? Then we started looking at two different cases. The case number one was when we had a size of the tank is different, but resistance is same. Resistance to flow is same. That is case number one. And case number two is size of the tank is different as well as resistance is different. And finally, the time constant of both the systems are same. Isn't it? So these are the two cases we have seen. So in both these cases, you can see that the ultimate response, you can see that if you look at the response of these two systems when the step input is given, in that case you can see that in the first case the output is, the ultimate value is exactly the same. Why? Because the ultimate value will be what? Kp. And Kp is what? R. And since R is same in both the cases, the ultimate value is going to be same. But speed of response for the second system is going to be sluggish compared to the first one. Why? Because in this case the time constant is lower. Time constant is given by A into R. Since this A is smaller compared to this A, time constant for this system is small, isn't it? And therefore speed of response will be high, isn't it? So you can see that for this particular system my speed of response is shown by red color, whereas for this first system the speed of response is here, response is shown by blue color. The second case study when the time constant is same. Time constant is same means speed of response is same. Isn't it? That means both the systems are going to reach to the ultimate value exactly at the same time. That is what happens here. You can see both the systems are reaching to the ultimate value exactly at the same time. But they will be reaching to different steady state values. Why? Because my steady state value, my final steady state value is given by what? Kp. And Kp is R. And R is different for both these systems here. You can see R1 and R2 are different. Okay? Is it clear? So this is what we have seen in the last class. Then we again started looking at a different system where we say the same time system is there, but the difference here is we are assuming that the outlet flow rate is proportional to the under root of H. That is what we typically get in fluid mechanics. So if you follow the physics of the problem, you will see that the outlet flow rate is actually proportional to the under root of H, not proportional to H, isn't it? We were taking proportional to H primarily because we wanted to analyze the system in a simple manner. That is why we have taken it proportional to H. But actually it is proportional to under root H. Okay. So if we take the outlet flow rate proportional to under root H, this particular term is non-linear. This non-linear term we have linearized. After linearizing and rearranging all the terms, what we get is this equation. Tau P df dash by dt plus h dash is given as kp fi dash. This is the same first order equation. Only the difference here is the time constant is defined slightly in a different way. So time constant in this case defined as 2a under root hs divided by beta. Now this particular time constant as well as kp, if you look at, kp is 2 under root hs by beta. If you look at both these constants are not constant. They are varying depending on the experiment you are performing. Every time you are performing the experiment, your steady state value is going to be different, and therefore your time constant and your kp is going to be different. But in process control, typically when you are trying to control a process, typically you have to have this kp and tau p constant. Then and then only you will be able to add the hardware unit to control it, isn't it? Isn't it? But that is not possible in this case. Why? Because this tau p and kp is varying with respect to the steady state value of the hs, isn't it? Similarly, if you are looking at the heater system, this time constant here defined as V rho Cp by UAT, and U is a overall heat transfer coefficient. This overall heat transfer coefficient is going to change every day depending on how much fouling of the heat exchanger took place. Fouling, corrosion, erosion, all that will lead to a change in the ultimate change in the overall heat transfer coefficient, isn't it? So clearly you can see that tau p and kp, these can vary in some cases whenever the system is non-linear. Remember, this is the case of non-linear system, and this is the case of non-stationary system. So whenever we have a non-linear and non-stationary system, you will see that time constant and kp are sometimes they can vary, isn't it? Isn't it? So how we can deal with such systems? We can deal with such systems either by having the constant values of each parameter for a particular time, and then we are going to update their values in a regular interval. So maybe we can have something like this: 10 days I am going to use a particular value, and after 10 days I am going to modify these values again, recalibrate these values again. Isn't it? So that is what the procedure people follow. There is another way of handling it. That another way we call it as a adaptive control. We will not be able to study in this course. I am not sure towards the end. If we get the time, we will cover that. What happens in the adaptive control? In the adaptive control, we find out this kp and tau p values regularly. So there will be some external another loop which will be finding out these values every time. So you are updating these values kp and tau p every time, and then you are performing the control. That is something called as adaptive control. And the third case is I can find out the relation how this time constant and kp are varying with respect to time. I can include that in the equation, and this entire equation then I can solve in a time domain. Isn't it? But then it becomes slightly more complicated. Okay. Alright. Then we started looking at the impulse response. So impulse response is what? Same first order process is there. So output in the deviation form divided by input in the deviation form is given as kp divided by tau ps plus 1. If you assume that the input is impulse response, in that case this f of s will be given by what? F of s will be given by 1. So f of t we are assuming as delta function. When I am saying the impulse input, what it means? F of t is a delta function. So f of s will be just 1. Laplace transform of delta function is 1, isn't it? So then I can multiply this one here, so we can get ys is given as kp divided by tau t plus 1. I can invert this into a time domain. What we get is kp divided by tau t e raised to the power minus t by tau. That is what the expression we are expected to get. We can plot this entire term kp divided yt into tau p divided by kp versus t by tau p. We plot the same characteristics which we have seen for the step input, you can find out this. So you can see that the entire response is completing in one time. If you find out this particular location is 63.2% of the ultimate response. Isn't it? Also around 4 time constant your response is going to be completed. Isn't it? So all the characteristics which we have seen for step input are still valid in this case also. Okay? Is it clear to everyone? Okay. Now let's make our life slightly more difficult. Okay, so far we were looking at simple, step input, no complications, nothing. Isn't it? Now what we are looking at is, let's say there is a first order system. So far we were taking the input as step input or impulse input. Instead of taking step input or impulse input, let's assume that the input to the first order process is sinusoidal. So f of s will be, let's say f of t is given as a sin omega t. So f of s will be what? F of s will be a omega divided by s square plus omega square. Isn't it? Correct? And the transfer function of the first order process is kp divided by tau p s plus 1. This f of s is given as a omega divided by s square plus omega square. I can find out ys. So ys comes out to be a omega divided by s square plus omega square into kp. I can divide this tau p here, so that becomes kp by tau p s plus 1 by tau. Now how to solve this equation? I have written this final expression here, but this final equation is after solving it. How to solve? Anyone? How you can solve? So whenever we have equations like this and we wanted to invert this into a time domain, what do we do? We find the roots of the denominator. What are the roots here in this case? In this case, this minus 1 by tau p is one root. That is perfectly alright. How about this? So this can be represented as s plus j omega into s minus j omega. So you have two roots here, isn't it? So c1 divided by s plus j omega plus c2 divided by s minus j omega plus c3 divided by s plus 1 by tau. Then you find out c1, c2, c3 by partial fraction. Isn't it? And if you put those c1, c2, c3 and invert back, finally you are going to get this. Okay. Can you work out this derivation? This particular derivation is not there in your system. Okay. Can you work out this derivation? Is it possible to everyone to derive this? You will have to find out a1, c1, c2, c3. If you rearrange everything, finally this is the expression you are going to get. Okay. So let's assume that you will be able to find out this expression. There is a shortcut also to find out this expression. I will not teach that now. We will go later and we will, discuss that. There is a shortcut to find out the expression. Okay. So once you get this equation, this is nothing but output. Isn't it? How my output yt is going to vary with respect to time t whenever there is a sinusoidal. Whenever there is a sinusoidal. Correct? Now this particular expression, you can see that cos term is there, sin term is there, these two terms I can combine, isn't it? So you can combine these two terms, so finally the expression which we are expected to get is this. A kp omega tau p divided by tau p square omega square plus 1 e raised to the power minus t by tau p plus a kp divided by under root tau p square omega square plus 1. Then sin omega t plus phi, where phi is nothing but tan inverse of minus omega tau. Okay. This is what the expression we are expected to get. This expression, so if I look at how my response will look like, okay. So see, typically the first order response is what? typical response in this case is expected what? If you look at the response will be something like this you are going to get. Isn't it? This is what expected to get in this case. So you can see that as t tends to infinity, what you are going to get? As t tends to infinity, when t tends to infinity, this particular term is going to become 0. Isn't it? When t tends to infinity, this particular term is going to become 0. And the remaining part is this a kp divided by under root tau t square omega square plus 1 into sin omega t plus phi. Isn't it? So if I look at this term, this is nothing but what? This is nothing but the steady state value of the response. Isn't it? When t tends to infinity, your response will be this a kp divided by under root tau t square omega square plus 1 sin omega t plus phi. So this is what the steady state response you are going to get. Isn't it? Now if you look at the steady state response carefully, you can conclude here what? You can conclude that whenever there is a sine wave as given as an input, in that case your output is also a sustained sine wave with same frequency omega. Remember, this omega is what? The frequency, isn't it? You have started with the input with frequency omega, isn't it? Your output will also have the same frequency omega. Isn't it? So your output at t tends to infinity is a sustained sine wave with a frequency omega. The only difference here is your output will be lagging behind by a phase angle of phi, and that phase angle phi is given as tan inverse of minus omega tau. Isn't it? Why we are saying that this is lagging? Because minus sign is here. This minus sign you can get it out. Tan inverse of minus of something, that becomes minus of tan inverse something. Isn't it? So it is phase lag. Your output will be lagging behind your input by an angle of phi. Isn't it? Correct? Is it clear? Another interesting thing to note down is this first term. Remember what was the input? A sin omega. But if you look at this output has a kp divided by under root tau t square omega square plus 1. Here kp is usually what we get, isn't it? Whenever we look at this response, first order process response, what we get? If the step input is there, kp into 1 minus e raised to the power t by tau. That is what we get. So kp anyway we get, isn't it? So if I look at the ratio of output amplitude divided by input amplitude is a. Output amplitude is a divided by under root tau t square omega square plus 1. If I take a ratio of that, what we get? We get 1 upon under root tau t square omega square plus 1. And that is something called as amplitude ratio. And you can see that this amplitude ratio will be less than 1. Amplitude ratio will be less than 1. So what it means? Your output signal will be always lower in the magnitude, lower in the amplitude with respect to input. Okay, so that is what is written. So this is something called as signal attenuation. Okay, is it clear to everyone? Now these expressions, again I am telling you, these expressions you can directly obtain. There is a trick. And why we are studying a sinusoidal input? There is a reason for that. We are not doing it just for the sake of looking at how mathematically complex is we are getting. It is not the aim. Isn't it? You will later understand that the sinusoidal input is a very, very important input in a process control, primarily because toward the end we are going to look at frequency response. Frequency response is an integral part of process control, and the frequency response is an integral part of process control because that enables you to solve the system along with their date time directly. Okay. Remember I said all the process control systems have date time associated with them, isn't it? You will see that later on. Whenever we have a date time associated with the system, and if you apply the frequency response, you can find out accurate solution of the problem easily by using frequency response. Okay. And when I am saying frequency response, what it means? It means that the input is periodic. Okay. So this sinusoidal input which we are taking here, we are taking with some purpose. We are not using this sinusoidal input to make our life more complex here, isn't it? There is a reason, primarily because later on we are going to look at frequency response where the input will be sinusoidal, and whenever we have a frequency response, it can solve the problem with date time without any modification. Without any simplification or modification, you can solve your system if these are associated with the date time by using frequency response. In fact, frequency response is the only method by which you can find out the solution without approximation, without any. Okay, clear? We will come back to this again later. We will come back to this again later, isn't it? Remember the syllabus which I have given. I am not sure whether you have seen the syllabus. After this, we are going to look at the second order system, then higher order system, then we are going to look at controllers, then we are going to look at feedback system, and after the feedback, we are going to start with the stability of the control system. We will start with route stability criteria, then we will start with root locus, and after that, there will be something called frequency. Okay, so frequency response is going to come as we go ahead. We are only making a base for that. Okay, we are starting something along the same line so that we will be able to connect it later. Okay. Alright. Can we go ahead? Now let's look at a interesting system. This system we are trying to model and see how the control can be done for this system, primarily because in the next semester you will have L14 process control lab. L333 or 331 CLP 303, that is process control. There is a process control lab is there. It is also associated with 1 credit course, isn't it, in which you are going to study instrumentation. Okay, so in process control lab, this is one of the experiments which you have to perform. You have to find out the dynamics of the thermometer and the lab thermometer, and that is why we are studying this thermometer system here. Okay, is it clear? So let's look at this particular system. So this particular figure is for what? This is a thermometer. Remember, thermometer at the end we have a mercury bomb, isn't it? So I am only showing the cross section of that mercury bomb. Okay, so you are putting this thermometer in the fluid and then you are trying to find out the temperature of the fluid which is there, isn't it? That's what you do, isn't it? So outside of this box there is a fluid. You can see that the outside surrounding temperature is T0. Ultimately you are interested in finding the T0. Okay, but as this T0 is different than the actual temperature of the surface of the thermometer, what will happen? There will be heat transfer, isn't it, from fluid to the thermometer. And because of heat transfer from fluid to the thermometer, this mercury is going to rise, and that rise in the mercury is going to give you what is the temperature of the fluid, isn't it? That's what the thermometer does, isn't it? Correct. So in this case, this is the heat transfer problem we are looking at. There is the outside temperature T0, inside temperature of the mercury is T, isn't it? And this is the mercury box, isn't it? Inside there is a mercury and this is a glass one. This is a glass one. So glass mercury is there. Inside there is a mercury box, and outside of this glass wall there is a liquid film. So you can see that this particular thing is nothing but the liquid film. Now what we are assuming that all the heat transfer resistance in this particular system, all the heat transfer resistance present only in this film. That is what the assumption number 1. Assumption number 2. All the thermal capacity is present only in this mercury bomb. That is the assumption number 2. And we are assuming the uniform temperature here. So when we get the uniform temperature here, anyone from heat transfer, when we assume that the uniform temperature is there, lump system. How we find out whether the system is lump or not? Biot number. Biot number should be less than a particular value. Then we conclude that the system is lump. Isn't it? Correct? So we are assuming that this particular part which is enclosing the mercury or the heat capacity is here and temperature inside the mercury bomb is uniform. That means Biot number is lower. Correct? And all resistance here is present only in this liquid film outside. Liquid film or gas film doesn't matter. Okay. The third assumption is, remember here the heat transfer is taking place. We are assuming that the glass wall is not expanding. The expansion is taking place only in the mercury, not the glass wall. So these are the three important assumptions. Okay. If you take these assumptions, in that case we can do the energy balance in this case. So what will be the energy balance? Heat transfer from the surrounding to this mercury, isn't it? And that will lead to the increase in the temperature, isn't it? So heat transfer from surrounding to the mercury will be given by what? HA T naught minus T, and that will lead to the increase in the temperature. So that will be given as mCp by T, isn't it? Now this equation, we can write down this equation at a steady state. So at steady state, this equation will become HA TOS minus TS, isn't it? Equals to 0. If I subtract this steady state equation from this, we will get this entire equation in a deviation form. We have obtained HA T naught dash minus T dash mCp dt dash by dt. If I rearrange the term, if I divide this entire equation by HA, we get mCp by HA dt dash by dt plus T dash equals to T naught dash. This is the similar equation what we have seen for the conformal term. We can define this particular term mCp by HA as time constant tau b. Tau b into dt dash by dt plus T dash equals to Kp in this case is just 1 and multiplied by T naught dash. If I apply the Laplace transform to this equation, we can get transfer function in this case will be what? Output in this case is temperature T. So T dash S and input is T naught. So T dash S divided by T naught dash S will be given by Kp divided by tau T. This is the typical expression which we are getting for the first order. Very often in the interview, this is the question is asked: what is the Kp value for thermometer case? For the thermometer case, the Kp value is 1. Okay, and time constant is mCp by mCp by. Okay. All right. Let us solve this problem. Chalo. Solve this problem. जागने का टाइम आ गया मेरे दोस्त, सामने देखो। आपका क्वेश्चन किस तरह से चल रहा है? You are sitting in the class, you are watching movie. किसको रीजन होगा? कि आपको गेम खेल रहे हो? कोई रीजन हो सकते हैं। but I have also been the student. I know. Student क्या करते हैं? ठीक है? So that is why people were, again having the internet in the night. Now the internet is throughout 24 hours, isn't it? Earlier it was only up to 12 hours. तो फिर आपके जो स्टूडेंट जो है ना क्या बोलते प्रतिनिधि, उन्होंने बहुत हंगामा करा सीनेट में, who wanted to work in the night, isn't it? I know what work they are going to do in the night. Isn't they want to play games. जिसको काम करना है वो दिन में भी कर लेता है, उसके लिए रात की जरूरत नहीं है, ठीक है? बट वो रहता है ना कि हाथी के दिखाने के दांत कुछ और होते हैं, खाने के कुछ और, तो वही बात, दिखाने के लिए बड़े दांत दिखाए जाते हैं, खाने के लिए so let's not go in the politics. But what I am trying to say, my friend, is please sleep 9 o'clock, wake up in the morning, ठीक है? और क्लास में ध्यान, सामने बैठ के सो रहे हो यार, तो सॉल्व करिए सब लोग, चलिए। So what is being given is thermometer having a time constant of 0.1. So tau P is given as 0.1. Then the steady state temperature, initially the temperature of the thermometer is 90 degrees. You have suddenly at time t equals to 0, you have put this thermometer into a bath with a temperature of 100. So T naught is 100, isn't it? Determine the time needed for the thermometer to read 90. दूसरा टाइम, तो फर्स्ट ऑर्डर सिस्टम रहेगा, यही इक्वेशन यूज करना है. व्हाट इज द सॉल्यूशन ऑफ द फर्स्ट ऑर्डर सिस्टम when we are having a step input? If we are having a step input of magnitude a, then my response y is given as a kp 1 minus e raised to the power t by tau p. That is what the expression you are expected to get. Time constant is given. Find out the magnitude of this step, isn't it? Kp value you already know for a thermometer case, that is 1. Everything is known in this equation. You find out the time at which you will get the temperature 90. What will be the magnitude of the step input? What will be the magnitude of the step input? 10. Because earlier the temperature was 90, you have suddenly put it in the bath of 100, isn't it? So 90, 100 minus 90, that will be 10. That will be the magnitude of the step. So A you already know, Kp is what? Isn't it? A already know, Kp is known. What will be the value of y dash? Y dash is y minus y steady state. In this case, t minus t steady state. Isn't it? So t value was 90. The t value is 98 and steady state value is 90. So you will get t dash equals to 8. So 8 equals to 10 into 1 into 1 minus e raised to the power t by tau p. Tau p value also you know, isn't it? It is given 0.1. You can find out t. Calculate the t. समझ में आया या नहीं समझ में आया? Same expression you have to use. Everything is known in this equation. क्या है? 0.17. This is what you are expected to get. Okay? Is it clear to everyone? So we stop here and we will continue from this point in the next class. I request all the students not to involve in the proxy. Please attend the classes regularly. And I am sure each one of you will get a pass grade. But if you do all this type of cheating here, you will definitely get a fail grade. And that is going to be more costlier. It's going to be more costlier. जिस कोर्स में कोई फेल नहीं होता उसमें आप फेल हो जाओगे. इससे ज्यादा और क्या है? इससे ज्यादा बेइज्जती कुछ नहीं हो सकती. जिस कोर्स में हर कोई पास हो रहा है वहां आप फेल हो रहे हो, है ना? ठीक है. चलो ओके, वी स्टॉप हियर एंड वी विल कंटिन्यू फ्रॉम दिस. क्या हुआ? बुक में बहुत ज्यादा आई डोंट थिंक ऐसा पढ़ा है. बकवास की चीज है बीच में. बुक से पढ़ा है. तो बात का है मतलब मेजरली तो फॉर्मूलास ही पढ़ा है. हाँ फिर उसमें एक दो छोटी छोटी